problems that deal with inequalities. So we talked about word problems before when they dealt with equations. Now we're going to be talking about inequality word problems. So instead of having two things equal, we're going to have a comparison between two values. Before we jump into that, we have to talk about just words that mean each of these inequality symbols. So if I say below or fewer than, that's strictly less than. If I say something is at most, at maximum, is no more than some number, that means it's less than or equal to that. It could be equal to it, or it could be anything less than it. Above, exceeds, more than, or strictly greater than. And then at least, at a minimum, and no less than means it's got to be that value or greater. So greater than or equal to. So you must be a minimum of 44 inches tall to ride Space Mountain at Disneyland or Disney World. So you have to be 44 inches or taller. So the inequality would be that x again, x here represents all the heights that you could possibly be. So x would be greater than or equal to 44. You could be 44 inches or you could be taller. So you could be 50 inches, you could be 44, can't be 43, can't be 34, you could be 60. Anything that's 44 or bigger. A bag can hold fewer than 20 cans before it's too heavy to carry. It can't hold 20. It's got to be less than 20. So x is the number of cans. That has to be less than 20. So we can't shade 20. We can't shade 25. We can shade 14, 4, and 18, not 21. That's too big. All right. Those are just basic words that mean each of those inequality symbols. Now we're going to embed those in word problems. So two-step inequalities from verbal situations. So we have this word problem where we just need to break down exactly what this is saying. You need to have at least $100 in your bank account to avoid a fee. You have $315 in your bank account, and you make withdrawals of $20 per week. For how many whole weeks can you withdraw money to avoid a fee? All right, so we need at least $100 in the account. You can see from the answers that is the end of our inequality. The number that you have in your account needs to be at least that amount. So it has to be bigger than that amount or equal to. So we're looking for greater than or equal to. It's got to be one of these two. This is saying that the money in your account would be less than that. That's not what we want. All right, the only other difference between these two inequalities is that addition and subtraction sign. So we have to really decide, what is this talking about? $20 per week. That phrase per week is saying that has to be attached to our variable, so it's 20W. That part makes sense for both of these. So is it addition or subtraction? We're starting out with $315, and we're taking away $20 each week, so we're subtracting $20 each week. When we solve that, the answer is W is less than or equal to 10.75. So the number of weeks is less than or equal to 10.75. Question says, how many whole weeks can we withdraw money to avoid a fee? So we're assuming that we're withdrawing $20 at the end of each week, I guess, here. So we're not going to round this up. Even though that number would round up to 11, we can't go up to 11 because that's too many weeks. This has got to be less than or equal to that. So 9 weeks, because 9 is the first integer less than 10.75 on the number line. 9 weeks is less than 10.75, but it's not the first integer less than 10.75. 10.75 would be there. 10 would be the next number. 9 would be after that. So 10, because that's truly the first integer, less than 10.75 on the number line. 11 is too big. Yes, it does round up to 11, but that's too big. All right, Michael went to the carnival with $22.50. He bought snacks for $5.75, and he wanted to spend the rest of his money on ride tickets. Each ride ticket costs $1.15. What's the maximum number of ride tickets Michael can purchase? All right, so we know we can't spend more than $22.50. You could spend all of your money, but we know that's the total amount that we could possibly spend, and the amount we spend has to be less than or equal to that. So this is the amount that we're going to spend. That has to be less than or equal to the money that we have. We're buying snacks for $5.75 to start, plus we're spending $1.15 on each ticket. That phrase, each ride ticket, that's telling you where your x is, because that's really what we're looking for. We don't know the number of ride tickets. That's got to be our x. So to solve this, we're going to subtract $5.75 from both sides. We get $1.15 times the number of ride tickets. It's less than or equal to $16.75. And then we'll divide by $1.15 on both sides. So that's the money he has left over for ride tickets. We'll split that evenly among the cost for each ride ticket, and that says that x is less than or equal to 14.56. So he can buy exactly 14.56 tickets and spend all of his money. But obviously you can't buy 0.56 of a ticket, so you can't buy a 15th ticket. You can only afford 14 tickets. Number 5 says a Starbucks manager is ordering new aprons and needs at least 25 to have enough for all of his baristas. The aprons are sold in boxes of 4. If the store already has 3 aprons, what's the minimum number of boxes that need to be purchased for everyone to have an apron? So they come in boxes of 4. Those are whole boxes. You can't buy half a box. So we're going to multiply 4 times some number of boxes plus the 3 that we already have, and we need at least 25. We could have 25. Seems like there's 25 baristas. We could have that number, or we can have more. So we'll subtract 3 from both sides. 4 times b is 22, so that's the number that we actually need to buy, and divide that by 4. So b is got to be greater than or equal to 5.5. So we need 5.5 boxes to have exactly the right amount. So that means we need more than 5. We're going to need 6 boxes. Alright, now we're going to create a scenario based on an inequality. So we're going backwards here. So given that inequality, 50 plus 28x is less than or equal to 400. Which of these scenarios matches that? Catering company charges a flat rate of $20 or $28. Already, I know this one's out. A flat rate, that's a one-time thing. You're not paying that over and over. It's $50 per meal. That's the thing that's happening multiple times. So this one's out. A flat fee or flat rate or a down payment only happened one time. Gym charges a fee of $50. That's a good start. That's a fee of $50 to join, and then $28 per month. That's another good part. $28 per month. If you have a maximum of $400 to spend, for how many months can you join the gym? That sounds perfect. Maximum of 400. We're saying that we can't spend any more than 400, so that amount has to be less than or equal to 400. I'm going to read the last one just to make sure that that doesn't make sense too. You need a minimum of 400 points to win a video game. Well, that one's out right away. If you need more than 400 points, you need a minimum of 400 points. You need your points to be greater than 400. I know I want my points to be bigger than 400 points there, so that's out because, actually, I guess it could be or equal to, but it doesn't matter. It's talking about this number being greater than or equal to that 400. Alright, now we're going to have more than one step involved. Parking garage charges $2.50 for the first hour and $3.50 for each additional hour. Dorian has $30 left on his parking pass card. How many hours will he park, or can he park for? Alright, so the first hour is $2.50. We're charged that right away. Plus, it's $3.50 for each additional hour. Now that might seem like we're just going to put H there. I'm going to label this as H. You might think we're just putting H there, but we already paid for the first hour. We don't want to be charged for that first hour again here. So this is kind of a confusing step, but we're going to talk about that value as H minus 1. We want to take away that first hour and then multiply that quantity, whatever that is, by that $3.50. We can't spend more than $30, so this value has to be less than or equal to $30. Alright, so that's for the first hour. This is for every hour after that first hour. We're taking away the first hour because we already paid for it here. So we're going to distribute. So 2.5 plus 3.5h minus 3.5 is less than or equal to 30. I'm going to combine like terms. 3.5h minus 1 is less than or equal to 30. Oh my gosh, I wrote it again. 30. I wasn't even doing this step right. We're adding 1 over, so it's going to become 31. And then we divide by 3.5. We get that h is less than or equal to 8.857. So we can park for 8 hours. We can't park for the 9th hour, and they're charging for whole hours, saying specifically how many hours. So we're not rounding this at all. We're going to spend 8 hours there, not a 9th hour. All right, Liam and Kenny are selling candy bars for a fundraiser. Liam sold some candy bars. Kenny sold twice as many candy bars as Liam. All right, so I'm going to say Liam is L. Kenny, I'm going to try to describe that in terms of how many Liam sold. So Kenny sold twice as many candy bars as Liam. So if I take Liam's amount, and I multiply that times 2, that would tell me Kenny's amount. Together, Liam and Kenny sold no less than 45 candy bars. Right, 3 possible amounts for the candy bars Liam sold. All right, so Liam plus Kenny, we know that's no less than 45. That has to be greater than or equal to 45. It's not less than it. It could be equal to it, but it's not smaller than it. Problem is, we don't know how to solve an equation like this. That has 2 variables in it. But I did just describe Kenny's candy bars in terms of Liam's candy bars. Instead of this K, I could say that's actually 2L. It's called substitution. In algebra, you learn more about this step, but that is called substitution, where we substitute something that we know to be equal to this in place of that. Now I can solve that just like I know how. I'm going to combine like terms, make that 3L, and then divide by 3. So L is greater than or equal to 15. So Liam could have sold 15, could have sold 16, he could have sold 17. Kenny could have sold 30, 32, 34. We know he sold twice as many. These are Liam's. These are Kenny's. Alright, last one. Lola, Violet, and Gabby are solving math problems. Together they must solve at least 50 problems. So actually, let's start there. At least 50 problems. Greater than or equal to 50. These are the problems that they're solving. That has to be bigger than or equal to 50. Lola solved some math problems. We're going to call that P. Violet solved 11 less problems than Lola. So we're going to do kind of the same thing that we did with Kenny and Liam here. Lola solved P number of problems. Violet solved however many problems Lola solved minus 11. It's 11 less problems than Lola. You take the number of problems she sold, you subtract 11, that would be the number that Violet solved there. I think I said sold, but I meant solved. Gabby solved 3 less than twice the number of problems that Lola solved. So Gabby solved 3 less than something. I'm subtracting 3. Subtracting 3 from twice that number, so 2 times P. So that's the number that Lola solved. This is 3 less than twice that amount. That's the number that Gabby solved. And we know that all together, this, and this add up to something that's greater than or equal to 50. P plus P minus 11 plus 2P minus 3. That's Lola, that's Violet, that's Gabby. Altogether, that's that's greater than or equal to 50. I'm going to combine like terms here. That's 4P. Combine like terms there. That's negative 14. We're going to start solving this by adding 14 to both sides. We get 4P is greater than, 4P is greater than or equal to 64, and then divide by 4. So P is greater than or equal to 16. So ultimately, we want to think about how many problems Lola must have solved. Well, it's got to be greater than or equal to. We can write it exactly like that. She solved at least 16 problems. Violet solved at least 5. Gabby solved 32 minus 3 is 29. I would actually just double check to make sure that makes sense. That plus that plus that. That's exactly 50, so they had to have solved more than those number of problems.